The important moment was bottom right side, before the eclipse. That flash was the C-class solar flares from the departing active region. There was a tight core rope of plasma within the axis of the ejection, and the CME could have been bigger, but much of that plasma fell back down to the sun, as you can see. This reduced but didn't eliminate the CME as we watched the coronal ripples in the eruption. CME was indeed small and aimed 90 degrees away from the Earth. Those coronal holes, the heliospheric currents produced by the CME, the below average seismicity for days, and the approach of two big planetary alignments in 7 days have us on earthquake watch in the latter half of this month. Here are the primary Blood Echo signatures from the last day at quakewatch.net. That's 1/3 of the earthquake prediction system. We're eyeing not just one event, but a considerable uptick trend over the next 10 days. Speaking of things beneath the ground, a terrible 2002 eruption at this volcano killed hundreds in the city, and that city's now doubled in size and more at risk. They say the lava lake is filling so fast we're 4 years from a major disaster, or sooner if it gets hit by seismic activity. The first paper today is so simple that reporting it will belie its importance. We can confirm that the energy supply into solar processes is anti-correlated with solar activity. It's juicing up and then it's discharging. A capacitor. Someone in the comments take a whack at explaining the plasma universe importance of a solar capacitor. I've got more stories to do. This is probably the most beautiful sight I've ever seen delivered by Hubble. The cloud of material has a glowing orange ember near the top of it, which we can tell is a newborn star furiously burning inside the cloud. What we're seeing on the periphery is the ionization of the cloud by the star, beginning a hot-cold phase interaction and separation amidst the excited versus non-excited gas and dust. Gorgeous. Folks, this next piece is the video accompanying a proposal to use a pendulum array to detect dark matter. They say that by monitoring the pendulums with lasers, they might be able to tell when a dark matter particle comes in and the interactions cause a uniform distortion to the background environment affecting them. There are, of course, a few problems with this. For one thing, there is no dark matter magic mystery particles. We have a movie and dozens of special episodes on that fact. But more importantly, let's play devil's advocate. According to them, there are billions of dark matter particles flying through your body every second. Even if we believe that their experiment could detect the signatures of this thing that isn't really there, they are supposed to be everywhere by all practical account, creating a homogeneous effect everywhere, not like one dark matter particle is someday going to encounter the device. Like they're not even thinking at all. There is a new call today from NASA for climate scientists to take in and understand a new discovery, but it's not like we really missed it. It wasn't always there, and in the unexpected regions of Senegal, a region modeled as nearly 100% desert, it actually has about 1.8 billion trees. While climate scientists knew it was not totally barren, they treated it as such in the models. It is worth wondering how much the extra plant food in the atmosphere helped with this in the recent years. Sure, we're nowhere near the levels of life explosion on Earth or what plants like in a greenhouse, and they've been CO2 starving for millions of years, and now our species is in an all-out assault on their food, but hey, trees. Top story today is a bit of a twofer. We are getting confirmation of the ocean changes and their accelerations. If you recall that the desalinization caused by the polar ice melt actually will trigger salinity anomalies in both directions in other parts of the oceans, here's a positive salinity anomaly near the location of Bermuda. But more importantly, they've confirmed that nearly all their key data points have decadal variability. Veteran observers know this is code for sunspot cycle forcing. Unlike the atmosphere, which has numerous minute-scale to days to 3-year lag periods for effect, the oceans tend to present forcing modulation on much longer periods with much longer lag. It is harder to spot those decadal signatures in ocean data, so kudos to this team even if they don't really seem to understand what they've discovered. In terms